Why do I start that way every time? Always because I'm happy. Something not too difficult today, kids. Nope, not going to lie. Not going to be not difficult. Especially after last night's homework. It's called the Remainder Theorem. Now, every time you see the word theorem, do you get like, whoa, that seems really complicated. It's got to be complicated. By the way, this is 5.4. Notice it's notes and classwork, so I'm going to teach you a couple things. And then I'm actually going to go through the problems, but I'm hoping that you actually do them on your own before you watch the trained monkey do them. By the way, all my videos, I say mine, only because my partner in crime's not here. She's awesome. Her name is Miss Vicky Newman. There it is. N for Newman, K for Krause. And we all know that math class takes forever, so we call it nkinfinity.com. My name is Mr. Key today because I'm going to be your answer key. Yeah, I know. If you've watched more than one of my videos, you've heard the same joke over and over again, and you're probably thinking, boy, this guy's lame. That wasn't nice. All right, so let's take a look at two questions from last night's homework. That's why it starts with 6. So hopefully in last night's homework that you probably just went over in class, or you may not have had time to go over in class, so I don't know. You did P of negative 5. Oh, you didn't do this. I don't know. This is new. Sorry, this is new. You did this. Now, if I review that real quick, and I'm only going to do that once for this one, is x plus 5 is equal, divided into x cubed plus 7x squared plus 17x plus, it's missing, I hate when it does that, plus 41. Somehow the 41 just sort of just disappeared off there. That's so weird. So if I do this math, I'm going to do it very quickly. X squared, you get x cubed plus 5x squared. You get 2x squared. Bring down the 17x. You put a plus 2x here. You get 2x squared plus 10x. You subtract. You get 7x. Bring down the minus 41. That's a positive 41. And you say, oh, plus 7 plus 7x. Hold on. Before I finish this, I got to do something. Got to start my calculator. Almost forgot. And then 7 times 5 is 35, so plus 35, and you subtract and you get 6. I don't know why I put a minus there. You get 6. Okay. So my question is now, wait a second, our divisor was x plus 5, correct? Our divisor was x plus 5. So I want to know if our divisor is x plus 5, and let's say I had a problem and I said, okay, factor this. And you factored something and it came up to be x plus 8 and x, excuse me, let me do x minus 8. And I said x minus 8 and x plus 5. And you factored it and you said, okay, what are the roots? Well, the roots would be x equals 8 and x equals negative 5. Agreed? So when I divide by x equals negative 5, I'm actually trying to see, I'm really trying to see is x plus 5 a factor of this? If it is, then x equals negative 5 would be a root. So when I come over here and I say, oh, what is p of negative 5? Let's see if we can figure out what p of negative 5 is. And we're going to do that in our calculator. That's why I got the calculator available to us. We're going to do that on the calculator. We'll figure out what p of negative 5 is. So we're going to come over here. And I'm going to go, okay. Negative 5, control var x. So I'm going to store negative 5 into x. I'm going to type that baby in. X cubed plus 7x squared plus 7x squared plus 17x. I think I would have had this memorized by now. Plus 41. 6. So this is equal to 6. Now, does that number sound familiar? It's the remainder. And when you did this problem last night, 7, did you get a remainder of 23? did you? So therefore, P of 3 is equal to 23. Now notice, not negative 3. It's the opposite of this. It's kind of like the, would be the root, if it was a root. So 3 would equal, P of 3 would equal to 23. Let's just check that one real quick. So we'll store 3 into our calculator. 3 control var x. And we'll type that in. 3x cubed minus 11x squared. 3x cubed minus 11x squared. Plus 22x minus 25 plus 22x minus 25. And you already see what the problem is. Do you see what the problem is? This is not going to be 23. It's probably going to be some ginormous. Look at that. Why would it give me that as an answer? Holy mackerel. That's because I left these all in exponent mode. So, you know how I always say, get out of exponent mode? I didn't tell myself that this time. Get out of exponent mode. I actually think I did. I might have to go watch the video evidence. But I don't think it registered, so that's my excuse. I'm absolutely going to stick with it. You can rewind and check. All right, I know you're all rewinding and checking, probably calling me a liar. You're a liar, Krause. You don't know what you're talking about. There it is, 23. So P of 3 is 23. So if I have a factor... Well, let's just do it this way. P of A is equal to the remainder. I mean, we just discovered that, right? We just discovered that P of A is equal to the remainder. Let's talk about this. Let's talk about it in absolute. I think I'm missing something that should be on your paper. I don't know why it's not there. So I'm going to write it up there. When P of X is divided by this, then the remainder will always be P of A. So if I take P of X, I thought I had this written on here. It may have disappeared again. Is it over X minus A? And I'm just going to divide. And let's say we come up with some, I don't know, some polynomial Q of X. Who cares what it is? Like up here, Q of X would be this thing. So it'd be... In this case, the answer would be x squared plus 2x plus 7 plus 6 over x plus 5. That would be the answer here, where this would be q of x, just some other polynomial, and this is my remainder part of the whole thing, is plus p of a, which, again, remember, that was our remainder, over x minus a. So what I'm trying to say is your remainder is really the functional value at that point. So let's try this. We're going to factor this baby. What is the remainder without doing any math? We're going to factor this thing. Let's see if we can factor this thing. We can't factor that. Oh. When I misread a question in mathematics, I realize it's time for some Dunkin' Donuts coffee. So that's what I'm going to do right now. Delicious and makes me smarter. Another nailed commercial. Need some more. All right, kids, let's read this question correctly. So x minus 1 is a factor of this. What does that mean? That means if I factor this thing, it would factor to something like x minus 1 and then some other stuff. So that means that when I divide x minus 1 in here, I'm going to get a remainder equal to 0. So when I because it's a factor, if I divide this into this, I will get a remainder of 0. Therefore, f of positive 1 is equal to 0. Now we're going to just check it. So we're going to come over to our calculator. We're going to just check this idea. We're going to stow 1 into x. We're going to check this idea. So it's x cubed minus 2x squared. X, now you know why I need my calculator. Cubed, get out of calculator, cubic mode, minus 2x squared. You don't have to get out squared, just cubes. Anything bigger than 3. Minus 5x, minus 5x. I'm so tired. Plus 6. And look at that. Remainder is 0 because it is a root. Or it divides unevenly. So there you go. So that's the remainder theorem. It's pretty simple. We're going to do a couple problems like that in class where I ask you to play around with that. But for the rest of the class, at this point, I'm going to just ask you to practice all these problems. So what I would suggest is don't watch me do these problems. I am going to do however many there are. And that's a lot. I can't even figure out. How many are there? There are 14 problems. There are 14 problems. I am going to do them. However, my peeps, I would expect that you, being the good students that you are, would not just sit here and watch me do these. Because first of all, watching an old bald guy for that long is sort of annoying. And you can go quickly through them. You can go much quicker through them if you just do them on your own. All right, but here I am. I'm going to start on this problem. So if you want to do it right now, stop right now. Pause her up. All right. Oh, hey, you're back. That's so awesome. What's the question asking for? Which points are restricted from the domain? All right, so we just got to figure out what our vertical and horizontal asymptotes are. Let me just grab my black pen. Ding, ding, ding. This would be my vertical asymptote. So I know that x cannot equal 3. Oh, all it's asking is about the domain. X can't equal 3. That's it. 2. I'm going to blow these babies up too, man. I'm just going to blow them up as fast as hard. All right. Determine the vertical asymptotes of this function. I don't know why I said vertical. I should have said determine the asymptotes of this function. All right, so let's see. I don't know. I'm trying to figure out why I just said vertical. I apologize. If you did this problem ahead of me, I'm trying to figure out why I just said vertical. I should have said and horizontal. So vertical lines are going to be x equals. What numbers can x not equal? Well, those are what make the denominator undefined. So what values can x not equal? X cannot equal 3. And, well, if it's asking what the vertical asymptotes are, that's a restriction on the domain. If I'm asking what the vertical asymptotes are, VAs, I should say x equals 3 and x equals negative 3, and x equals positive 1. Now, the horizontal asymptote, if you remember, is a ratio of the leading coefficients, but this one I need to figure out what the denominator is. So the numerator is just x squared minus 9. The denominator, if I factor it all out, is going to be x squared and then some other stuff. Right? It's just going to be x squared, and I don't really care about the rest of it because the leading coefficients are right here, and that would be 1 over 1. So my horizontal asymptote would be y equals 1. Now, I would suggest at some point you probably come over here and just check this thing out. I mean, it doesn't hurt to just graph it real quick. So hit control division. X squared minus 9 over parenthesis x plus 3 parenthesis x minus 1. Enter. So, let's see. Oh, by the way, I'm allowed to graph x equals lines. I wonder how I do that. I hit tab. I'm trying to remember how to do this. Tab. Hit the back arrow, back arrow. Oh, I didn't update the software on this one. Oh, you can do x equals lines, but I didn't update the software. Why is it that the only restriction is x equals 1? Why can it look like x equals 3? Or negative 3? Why do I not have a vertical asymptote at 3 and negative 3? Why do I not have a vertical asymptote at x equals negative 3? I mean, I can't have x equals negative 3. Check this out. Control table. Notice at 1, it's undefined. Let's go take a look at negative 3. Negative 3 is undefined. So why is there not an asymptote at negative 3? Control T. Get rid of that. Let's do this. Let's blow things up. Let's go menu, window, and zoom in. And I'm going to zoom in at negative 3. Oh, man. It's not letting me zoom in. Menu, window, zoom in. Center. Now I don't know where negative 3 is anymore. It's over here somewhere. Well, it should show a hole. Apparently, it's not showing it. Now, while x equals negative 3 is a restriction on the domain, if I factored that numerator, wouldn't it be x plus 3, x minus 3, all over x plus 3, x minus 1? While x can't equal negative 3, we will not have a vertical asymptote underneath there. So I apologize. I probably shouldn't have given you that as a problem because we really haven't talked about that idea yet. Moving on, kids. Determine the asymptotes of this function. Okay, let's see here. Normally my asymptotes are what? Y equals 0 and x equals 0, correct? So what did we do here? We moved left 1. So that's going to modify the vertical asymptote. So that means my new vertical asymptote is going to be left 1. So that's x equals negative 1. What did I do here? I moved down 2. That means my horizontal asymptote is going to shift down 2. So my new horizontal asymptote is y equals negative 2. Now this negative has nothing to do with the asymptotes. That's just a reflection. So don't get confused by that. All right, children, let's see what we got here. I can't find my mouse pointer. There it is. All right. Hate when it does that. Hate it. All right, let's grab red. All right, so what are my restrictions on the domain? X plus 2, x minus 2. So I would expect an asymptote at these two places. Those would be vertical asymptotes, would be x equals negative 2, x equals positive 2. But you know what? Since I had that problem before, I'm going to try again. Get out of this. Don't save it. Go back into graph mode. And let's just check. Why not? Control division. Oh, before I do that, let's see what I think the horizontal asymptote is. The horizontal asymptote, remember, is a ratio of the leading coefficients so long as their degrees are the same. And I think I forgot to say that last time. So long as their degrees are the same, it's the ratio of the leading coefficients. So in this case, my horizontal asymptote would be y equals 3. Let's check it out. Oops, I don't want you. I want you. I want you. 3x squared. 3. I know. You're thinking, Mr. Krause, you should have gone into show business with that voice. You know, nobody's got it better than me. Let's see what we got. Oh my goodness. Oh, it looks like we have a vertical asymptote at x equals negative 2 right here. It looks like we have a vertical asymptote at what is this? Oh, x equals positive. And it also looks like I have a horizontal asymptote right here at y equals 3. At y equals 3, I have a horizontal asymptote. All right, there we go. We did it. Yay! All right, I think we're done with asymptotes. I don't get to say asymptote anymore, and that really bothers me. All right, kids. Okay, rationalizing denominators. Let's get them to be a rational number. This is not a rational number. It is an imaginary number. So we need to get rid of it by multiplying. What's that special word? That's right. It's called the conjugate. It's 2 minus 3i. 2 minus 3i. All right, let's see. If I do that, the numerator I get, now remember these ones I want to distribute. I get 6 minus 9i all over 2 times 2 is 4. Now because it's because they're conjugates, I don't need to do all of this terms. I'm just going to do these two, which is minus 9i squared. Yes, Johnny and Jill and Mary and Jane and all these other people. Those are married couples. You can't cancel that 9 and the 9 there. Look, so you're like, yes, 9's cancel. Yes, just do it. And then 1i cancel. Not going to happen, kids. Can't do it. Don't mess with that. The numerator is a married couple and they want to stay married. Now, the denominator's got some issues. We've got this I squared. Now, I know I squared is really just negative 1. So I got negative 9 times negative 1. That's really plus 9. So 4 plus 9 would be 13. Of course, my answer key is wrong, so I'm going to have to go over here and make a little in my answer key so I know to go back and fix it, because that's embarrassing. Because I put plus. What happened was I accidentally put a plus there. So embarrassing. So embarrassing. All right, so let's try this one. The numerator is not the problem. It's the denominator. So we have to multiply by the conjugate. The conjugate is 2 minus I. 2 minus I. How many minutes are we into? That's not you. All right, we can do this one. So in the numerator, let's do the denominator first. In the denominator, I just have to do 4 minus I squared. And I might as well finish going through that. 4, and then this is really minus negative 1. So isn't that really just plus 1? So I got to get a 5 here. Yay. All right, so in the numerator, though, got to do some work. 10 times 2 is 20. 10 times negative I is negative 10I. 2 times negative I is negative 2I. And then negative I times negative I is positive I squared. Okay, but if I remember that this is really negative 1 here, so it's really adding negative 1. So 20 minus 1 is 19. And negative 10i and negative 3i is negative 12i. Catching! I'm just curious because I forgot. I'm going to put this in my calculator. I don't remember. Honestly, I don't remember. I'm thinking it'll help me out. What do we have? Control division. I don't know if it's going to. But I'm going to check anyway because that's what I do. I don't... Do you do that? I do that. Do-do. Do-do. You said do-do. Oh my God, you said do-do. 2 plus I. 2 plus... I know. I'm like a 5-year-old kid. Enter. It rationalized it for me. Now, what it wrote it as is 19 over 5. So if I take this part right here and I write 19 over 5 minus and then 12i over 5. Same thing. In fact, this would be actually probably better answer because this is in what's called A plus BI form. The real part and the imaginary part. So you probably can't see this behind my head. The real part and the imaginary part. So, wow, isn't that weird? It does it for me. My calculator helps me. I love my calculator. By the way, that's only the TI Inspire, not the TI 84. I don't believe the 84 does that. I'll be back after I have a little bit of coffee and I save this video. If only kids knew that coffee makes you smarter, Dunkin' Donuts, we'd be rich. Dunkin' Donuts, it makes you smarter. No, it doesn't. Oh, it doesn't. It just gives you high blood pressure and an increased heart rate. Probably wear out your heart earlier. Makes you a little crazy. I am like a walking advertisement probably for not drinking coffee. Just going to say. All right, so here we go. What do we got? Oh, so this radical x is a problem. We're going to rationalize this by multiplying by the conjugate. So I'm going to multiply the exact same thing, but 1 plus radical x. 1 plus radical x. So in the numerator, I'm not going to distribute. I get radical x times 1 plus radical x. I might think about it later, but I don't know. I may not. And in the denominator, I get 1 times 1 is 1. Negative radical x times positive radical x is just minus. And what's radical x times radical x? X. That's why we do it. Done. If you wrote this is probably a cleaner answer. Square root of x plus, if I distribute this, plus x all over 1 minus x. The reason I probably, I struggle with doing that because I'm going to get some fool that does this. Oh, look at Mr. Krause. The x's cancel. That's a married couple. You can't break up the married couple. Don't do that. Don't do it. Not going to do it. Going to get in trouble. There's your answer. Adding and subtracting, you are not allowed to cancel or divide out common factors. Don't do it. All right. The problem's the denominator. So is this the same denominator, or is this just... Oh, ooh, look at me. I went from minus to plus. But that's okay. The numerator is a lot more complicated. And because the numerator is complicated, we are going to have to distribute. So, yes, you guys are so excited. So in the denominator, because that's easier, I'm just going to take care of the denominator. 1 times 1 is 1. Negative radical x times positive radical x is just minus x. That was the hard part. 7 minus 7 radical x minus 2 radical x, and then negative 2 radical x times negative radical x is positive 2x. Nothing. Oh, wait. We can combine in the numerator, so we get 7 minus 9 square roots of x plus 2x all over 1 minus x. That's cool. You can leave it like that. Hey, I didn't get the answer key right. Why is that not going down? Go down, go away, go away. Where's 9? Oh my gosh. Fractions, divisions. It's so fun. Do you remember that this is the one that's going to get flipped? Because it's divided by, that's the one that's being divided. So we're going to go, and because I'm going to flip that one and I want to think about it, I don't want to make a mistake, I'm going to do it right now. X minus 2. And x minus 2 is the easiest thing there. The numerator has a GCF of x. So I'm going to take an x out. X minus 6. Uh-oh, alert, alert, highlight it. Highlight it. What are you thinking about when you see that? What are you thinking about? What are you what? Oh yeah, -1 rule. It's backwards. It's backwards. Leave it backwards. Don't flip it around because it doesn't feel right. Just because it doesn't feel right doesn't make sense. You just leave it the way it is. It's x plus 6 plus x, 6 minus x. This is the problem right there. And the denominator is not bad. It's x and x. What multiplies to 12 that adds up to 8? I would guess plus 2 and plus 6. So let's see what we got here. This plus 6 cancels with this plus 6. That counts as outright because addition is commutative. This plus 2 cancels with this plus 2. Now be careful. This does cancel with this, but it makes a -1. All right, that's it. What's left over in the numerator? -1. What's left over in the denominator? Look at it. It's right there. X. There's your answer. -1 over x. I had to pause that, kids. Another mistake in the answer key, but I'm going to fix it. I'm going to fix it. Oh my gosh. I love finding my mistakes in the answer key. What happens is I do a little bit of work too fast, and I make mistakes, and then I get embarrassed. But that's okay. If f of x equals this and g of x equals this, find f of g of x. Now this looks, oh my gosh, it looks so complicated. Oh my gosh. See, it's all this words where it's really just saying find this divided by this. Well, if this is the one that's being divided by, it's the one that gets flipped. All right, so we're going to change it to a multiplication problem. And that one's getting flipped. So this goes to the denominator. So I'm going to do that one right. That one goes to the denominator. I'm going to do that one first just so I know it. But that 3x squared thing kind of scares me, so I'm going to come back to it. So multiplies to 12 and adds up to 7. X and x. And they both have to be negative. Because they both have to be the same sign. They both have to be negative. So that'd be -3 and -4. Multiply to positive 12. Add up to -7. I'm going to come back to that one just because it scares me a little bit. Let's do these two. In the numerator, I can take out a 3. And I'm left with x squared minus 9. But that bothers me. So let's do 3x plus 3. X minus 3. So let me get rid of that. Ding, 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 ding. All right. In the denominator, I can take out, let's see, I can take out a 2. I can take out a 3. If I can take out a 2 and a 3, I can take out a 6. Let me take out the 6. 6. I end up with 3x plus 5. So now I'm going to come back to the hard one. I know it has to multiply to 3x squared, so I know it has to be 3x and x. And I'm thinking, wait a second, I have a 3x plus 5 here, so there's a good chance that's going to be a 3x plus 5. And 5 times what gives me 20? Oh, 4. And I see I have an x minus 4 here, so this is probably x minus 4. Now, that doesn't always work, so you probably should check your answer. Let's check. 3x squared, perfect. This is minus 12x, and this is positive 5x. And that adds up to negative 7x. And what do I want? Oh, I want negative 7x and negative 20. Perfect. So sometimes you can cheat to get the harder ones right. All right, so now that we've got all of this stuff done, now I can just start lopping all the stuff off. By the way, do I have any negative 1 rules? Do I have anything backwards? I don't see anything backwards. All right, so this 3x plus 5 cancels with this 3x plus 5. This x minus 4 cancels with this x minus 4. This x minus 3 cancels with this x minus 3. And I'm left with, wait a second, 3 goes into itself once, 3 goes into 6 twice. So now if I go along and I highlight all the stuff that wasn't canceled, I got the 1, I got x plus 3, nothing else, and 2. So my answer is, in all of its glory, x plus 3 all over 2. Yay! This is the kind of problem that you say when your mom says, if you work real hard, you can get it. And you're like, all right, Mom, why don't you help me out with this problem? Watch them run. Watch them run. And then you just take out your pencil and you just say, oh, this isn't bad, Mom. This is an easy problem. This is the easy problem in math this year. Easy. I can handle this one. You can't even look at it. You're scared. I know you're scared, Mom. We're going to turn it into a multiplication problem. Don't scare your mom. Your mom loves you. She only wants what's best for you. By the way, I want you to look at this real quick and go, alert, 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 if, in fact, you see an opportunity for a negative 1 rule anywhere. Anybody? Anybody? There is one. I'm going to highlight it. Do you see it? Negative 1 rule anywhere, anywhere. Alert! There it is. Do you notice that the squared term comes second and I have subtraction? So there's a really, really good chance that's going to be the negative 1 rule. This one's going to get flipped, so I'm going to do it right away. X minus 4 goes in the denominator, and in the numerator, we just factor that baby. This one comes in the numerator. The signs have to be the same, and they both have to be negative, and that's an easy one, negative 4 and negative 4. I'm going to take care of this highlighted one next. It has a GCF, so I'm just going to take out the x, and I'm left with 5 minus x. Don't turn that around because it makes you feel better. Don't care about your feelings. Your feelings will get you the wrong answer. All right, the rest of them aren't bad. This one, the signs have to be different, so I know I need 1 plus, 1 minus. And since this is a 1, the numbers have to be right next to each other, 3 and 4. 3 and 4 multiply to 12, and they have a difference of 1. I just want to make sure my difference is negative, so I'll make the larger one negative. All right, this one I can just take out an x minus 5. And in the numerator, I have the dots, difference of 2 squares. X and x, we got a plus 3 and a minus 3. So let me start lopping stuff off. Let's see. I'm going to take care of the negative 1 rule right now so I don't screw it up. It's right here, x minus 5 and 5 minus x. And I'm just going to put the negative 1 right there. It doesn't really matter where I put it. So x plus 3, x plus 3. X minus 4, x minus 4. X minus 4, x minus 4. This x cancels with that x. So I'm left with negative x minus 3. Or I could write negative x plus 3, but why bother? Why try it? That's it. I'm good. That's all. That's all she wrote. That's the answer. All right, look along, look along. Do you see anywhere you might have a problem and sense that there might be the negative 1 rule? Looking along, looking along, looking along, looking along. Whoa, negative 1 rule. Looking around, looking around, looking around. What? Negative 1 rule? I got it twice? What's a negative times a negative? Positive. We're going to see how this one plays out. All right. I'm going to take care of the last one first, only because it has to get flipped, and I want to make sure I don't forget to flip it. So, In the numerator, I'm going to take care of this. It has a GCF of 8x, so I'm going to take an 8x out, and I'm left with 2 minus x. Yep, see, it's backwards. The numerator, they have to multiply to negative 28. That tells me the signs are going to be different. And they have to add up to 3 and positive 3, so 7 and negative 4. I hope you didn't have a problem with that. All right, let me take care of this one. It's got an x as a GCF. I'm left with 8 minus x. Okay. The numerator, x and x. Negative 2. That means one's got to be positive, one's got to be negative, and there's only one way to multiply to negative 2, but because they have to add up to positive 1, the bigger one has to be positive. This one's easy. X plus 2, x minus 2. And notice that middle term is a negative 1 over here, right? See this negative 1? This tells you the numbers have to be right next to each other. And what two numbers are right next to each other that multiplies to 56? 7 and 8. And because they have to add up to a larger one, the larger one has to be negative. All right, let me grab my green tool because it's like Christmassy or holiday-y. All right, let's see. I'm going to take care of my negative 1. Do I even have a negative 1 rule? Okay, I got this x minus 8 and this x minus 8. I got 8 minus x. There's a negative 1. I also have this 2 minus x and this x minus 2. That's another negative 1. Well, what's going to happen to those two negatives? They're going to turn into positive. So just because you have the negative 1 rule doesn't mean you're going to have a negative answer. I got two negative 1 rules. They're going to kind of like offset each other. Let me keep going. X plus 7, x plus 7, x plus 2, x plus 2. This x divides and gets rid of this x. Is there anything left over in the numerator? So let me highlight what I got left. I got a negative 1, I got a negative 1. They make positive 1. I got an 8, and I got an x minus 1. Anything in the denominator? Nothing, 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 nothing. Oh, I got this thing over here. So here we go. Our answer, negative times negative is positive, so those just cancel. 8 x minus 1 all over x minus 4. Two problems left, kids, and I'm not going to lie, these problems are fun. Does that look like reindeer? The reindeer theorem? The reindeer theorem. Oh, I love reindeer. Good old Rudolph the Red-Nosed Reindeer. All right, let's rock and roll on this thing. We have to use long division and then check your answer using the remainder theorem. All right, so here's what we're going to do. We have to do two things on each of these problems. So it's kind of like 4 problems. Let's do it. X minus 2. X squared minus 8x plus 18. Now, the good thing is I only gave you a quadratic. So x times x is x squared. So this gives me x squared. X times negative 2 is negative 2x minus, but those minuses make a plus. So I end up with negative 6x plus 18. X times negative 6 is negative 6x. So negative 6x. Negative 6 times negative 2 is positive 12. Not 2. Positive 12. Negative. That makes this positive. That makes this negative. And I end up with 6. So the answer to this question is x minus 6 plus 6 over x minus 2. Now, how do I check it using my remainder theorem? If this is my divisor, x minus 2, I need to verify that p, was it p? Didn't tell me. Whatever. I'm going to use p. P of 2 is equal to the remainder that we got, which was 6. I got to verify that p of 2 is equal to 6. Now, because I said show using the remainder theorem, you have to actually show the work. So we're going to take this function, x squared minus 8x and plus 18, and we're going to plug in 2. So 2 squared minus 8 times 2 plus 18. Math's not too difficult here, kids. This is 4 minus 16 plus 18. Let's see. 4 minus 16 is negative 12. Negative 12 plus 18 is, in fact, 6. Yes! Nailed it. One last problem. By the way, don't watch me do this last problem. Try it on your own. See what you can do, and then you do the Remainder Theorem on your own. All right? All right, we got it. I got time. Did you pause? Pause! Scary job. Sorry. All right, let's do this. X plus 3. X plus 3 divided into 2x cubed plus x squared minus 8x plus 5. All right, so x times 2x squared is 2x cubed, so 2x cubed. And then 2x cubed times 3 is plus 6x squared. Minus, so this gives me negative 5x squared minus 8x plus 5. So x times negative 5x gives me negative 5x squared, so negative 5x squared. Negative 5x times positive 3 is negative 15x. Subtract, which turns this into a plus, which turns this into a plus, which gives me 7x plus 5. I feel like I didn't write that. Okay. And then plus 7, right? So 7 times x is 7x. 7 times 3 is 21. Subtract, and I get negative 16. So in order to verify that I got this correct, excuse me, I need to check P of negative 3 and verify that it equals negative 16. If that's true, that's what's going to equal. All right, so let's do this. So the cubic is 2x cubed. I'm losing my voice for some reason. Excuse me. Plus x squared minus 8x plus 5. So we're going to take this baby and we're going to plug in negative 3 in here, in here, and in here. So 2, negative 2 cubed plus negative 3 cubed plus negative 3 squared minus 8 times negative 3 plus 5. Let's see. Negative 3 times negative 3 times negative 3 is, this is really negative 27. So this becomes negative 54 minus plus 9, because negative squared is positive, plus 24 plus 5. Holy crapola. Let's see what all this is. Let's see, that's 14 and 24 is 38. So it's negative 54 plus 38, which is negative 16. Yay! All right, kids, that's the Remainder Theorem. That's the new topic for the day. We got a little bit of review in. I hope you did okay. Hit the subscribe button, hit the like button, thumbs up. No thumbs down. Why would you use thumbs down? It's math. You get thumbs down math. That's ridiculous. Catch you on the flip side, kids. Bye. Bye.